This is an example problem involving uh, drawing a graph, graphing a function that has a slant asymptote. And we have several different parts of this problem that we're going to complete, starting with part A, state the domain of the function. So remember that when you're looking at domain, you really just want to know when would your denominator be zero. You are not allowed to divide by zero. So just take that denominator, set it equal to zero, and realize that, all right, so this is factorable. X squared minus 1 is a difference of two squares. It's x plus 1, x minus 1. And set each of these equal to 0 and solve, and we'll see that we have -1 and +1. So our domain is everything but these two values. When I plug in these two values for x, I get 0 in denominator, not allowed to divide by 0, not part of my domain. So it's all real numbers except x equal to plus or minus 1. Next part, my intercepts. And before I do my intercepts, let's just point out here quickly that notice that you cannot simplify x cubed over x squared minus 1. So it's not like I have any common factors here that I can cancel out. So this is the simplified version of this function. And as always, when I'm finding my x-intercepts, I'm going to set y equal to 0 and do the math. When I'm finding my y-intercepts, I'm going to set x equal to 0 and work out the math. So let's do that. So with my x-intercept, I'm setting y equal to 0. There's my y. F of x is y. So 0 equals x cubed all over x squared minus 1. This fraction here, when is this going to equal 0? Well, the only time that this fraction is going to equal 0 is if my numerator is 0. And you can think of this as multiplying both sides by x squared minus 1. 0 times x squared minus 1 would cancel out. When does x cubed equal 0? What number multiplied by itself 3 times would give you 0? And that value would be 0. So my x-intercept is at x equals 0, which is at my origin. Let's work out my y-intercept. So with my y-intercept, I'm going to set x equal to 0. So now I'm basically evaluating this function at 0. So I have 0 cubed all over 0 squared minus 1. And 0 cubed would be 0. 0 squared is 0 minus 1 is -1. Divide by 0, and I know that f of 0 is 0. So my y-intercept is at y equals 0. So basically, my intercept, my only x and y intercept is at the origin. So it's just that one point. So let's go and let's plot that. So here is this is going to be my graph. Right there is my x-intercept and my y-intercept right there at the origin 0, 0. Okay, that takes care of part A and part B with the domain and the intercepts. Let's move on to the asymptotes. Now, one thing you'll notice in this example is that they don't even mention horizontal asymptotes. And the reason they're not mentioning it is because there isn't one. My degree of my numerator is 1 larger than the degree of my denominator. Anytime the degree of the numerator is bigger, no horizontal asymptote exists, but we do have that slant asymptote because of it being 1 larger. All right, vertical asymptote. So with my vertical asymptote, I just want to know when is my denominator equal to 0. And we just calculated that a little bit ago when we worked out the domain. Set x squared minus 1 equals 0. Solve it. We're going to get plus or minus 1. So my vertical asymptotes are at x equals plus or minus 1. The only time where the vertical asymptotes are going to differ from the domain is when you can simplify this function. Anytime you have common factors that get canceled out, that's where you might have a case where domain and vertical asymptotes are not the same. Not happening here, so they are the same. So let's draw in our asymptotes here. So I'm going to put a vertical asymptote here at x equals -1. And I'm going to put a vertical asymptote here at x equals +1. Right. Slant asymptote. This is where I got to do the long division. I need to take x cubed. Let's put in these placeholders here. And I want to divide x cubed by x squared minus 1. Start by doing x cubed divided by x squared. That would be x. X times x squared is x to the third. X times negative 1 would be minus x. So I'm going to subtract x cubed minus x cubed. Those are gone. 0x squared minus nothing, there's nothing there. 0x minus negative x, it's the same as adding, so this will be positive x. And at this point, the degree the degree of this is 1, and that is smaller than the degree here. So this would be my remainder. Don't need to worry about it when I'm dealing with slant asymptotes. All I need to worry about is this guy right here, my quotient. I have this x here, and really all I got to do is add in y equals, and I'll have my slant asymptote. So my slant asymptote is the line y equals x. So let's add that into our graph. So if I have a slant asymptote at y equals x, so I know my y-intercept would be 0, my slope is 1, so I go up 1 over 1, up 1 over 1. So really, this is going to go through this point here. It's going to go through 10, comma 10, right, 10 up 10. That would be on the line y equals x. And it's also going to be at negative 10, comma 10. So let me get my dash line. I'm going to go from here all the way up to here. And there it is. There's my line y equals x. So I've drawn in my vertical asymptotes. I've drawn in my slant asymptotes. I have this intercept here, which is part of my graph. The rest is just filling in the rest of the points, which can be a somewhat tedious process just because you have so many different parts of the graph to deal with. So we need to know what is happening graphically over here to the left. Where am I at? And one thing I want to mention before I even start graphing this is as I move out to the left, this slant asymptote, what's going to happen is my function is going to approach it. Now maybe my function is going to approach it from here, from above it. Maybe it's going to approach it from here, below it. But one way or the other, I'm just going to drift closer and closer to this slant asymptote. Same thing up here. So as my x values get larger and larger, my graph is just going to kind of run into this wall right here. Same thing with these vertical asymptotes. Either it's up here or it's down here, right here or right here. So let's start plugging in points and find out where it's at. Let's go at negative 8. Just plug in negative 8 and see where we are. So if my x value is negative 8, so I got to do negative 8 cubed. So negative 8 times negative 8 times negative 8. That's going to be negative 512. And I got to take care of my denominator. Negative 8 squared. Negative 8 times negative 8 is 64. 64 minus 1 is 63. So now I have negative 512 over 63. And if you type in negative 512 divided by 63, you're at about negative 8.12. So let's plot that point. So I'm going to go left 8, down negative 8.12, so I'm about right here. Okay. Next point, I'm going to plug in negative 3. So if I do negative, you can pick whatever points you want. There's no rhyme or reason here to why I'm picking negative 3. But negative 3 to the third, negative 3 times negative 3 times negative 3 would be negative 27. Negative 3 squared is 9. 9 minus 1 is 8. Negative 27 over 8 would be negative 3 and 3/8. So negative 3 and 3/8, let's plot that point. So negative 3 on a -3 3/8, so not quite at that mark, about right there. All right, let's do one more point. Let's get close to this -1. Let's plug in -1.5. All right, so do -1.5 to the third power, that's -3.37. And -1.5 squared would be 2.25, and then subtract the 1, that would be 1.25, and work out that division, you're at about -2.7. At -1.5, -2.7. Right there. All right, let me plug in one more point. It's very close to this -1. Let's plug in -1 point. All right, and if I work out this math, -1.1 to the third, work that, take that in your calculator, and then divide it by, group this together in your calculator, do -1.1 squared minus 1. Make sure you can get this, but if you do it correctly, you should be at about -6.3. So at -1.1, I'm down here at about -6.3. And that means that this, let's see if I can draw this. Do something like this. And it's very difficult to draw a nice straight line with this graphic tablet that I'm using. If you're using pencil and paper, I'm sure you'll be able to do a much better job than what I just did. It's something like that. Now, to save you a little bit of time, I'm not going to go through every single point in here and every single point in here. This video is already getting kind of long as is. But I will tell you what you should get in those sections and what you'd want to plug in. Well, we already know what's happening at 0, but plug in something close to -1, maybe -0.9. Plug in something close to 1, maybe 0.9. Find out where your output is, and then plot the points. And over here, maybe I would plug in 1.1, maybe a 2 or a 3, and then maybe an 8 or a 9, something out here. But if you do all these steps correctly, this is what your final answer should look like for your graph of this function. And if you want more specific values here for your table of values, notice I have a lot of points that I ran through here. So the -0.9, you should be at about 3.83. The 3.8 is enough. Plot that point. We already have the 0, 0 at the y-intercept. 1 is, of course, undefined. We didn't have that value as part of our domain. You can't divide by 0. The 0.9 was at -3.83. So you plot those points. So -0.9, 3.83, that's about right there. And there's that 0, 0. 0.9, -3.83 is about right there. And just draw your graph so that it runs kind of along that asymptote. That's that section right there. And this section right here is with these points. So you can see exactly where each of these inputs go in terms of their outputs. And there's how they all, where they are at. If you plot them, your final answer once again looks like that.